Imagine you're working on a project, things are going well, and then one bad change blows everything up. You know the file worked yesterday, but now you can't remember exactly what changed. Maybe you overwrote the wrong section. Maybe you delete something important. Maybe you panic trying to fix it fast and somehow make it even worse. This is the problem Git is designed to solve. In this video, I'm going to show you what Git is, the core ideas you actually need, and why this tool matters so much in Linux and software development. If you're new to version control, this is the foundation that makes everything else in Git start to make sense. Git is a version control system. Version control means tracking changes to files over time so that you can review history, compare versions, restore earlier states, and collaborate with other people more safely. If you've heard of Subversion or SVN, that was another major version control system that many teams used before Git became the default choice. Git is specifically a distributed version control system, which means every copy of a Git repository contains the project history, not just the latest files. This is one of the big reasons Git was seen as a major step forward from SVN. Subversion depends so much more on a central server, while Git gives each developer a full local copy of the repository history. That makes Git faster, more flexible, and much better suited to branching offline work and modern development workflows. But for beginners, the most important idea is simpler than that. Git lets you save meaningful checkpoints in your work. Those checkpoints are called commits. Why is that so important? First, Git gives you history. Instead of guessing what changed, you can inspect the exact differences between versions. Second, Git makes experimentation safer. You can try something new without feeling like one mistake is going to destroy your entire project. Third, Git improves collaboration. Multiple people can work on the same project without constantly copying files back and forth and hoping nothing gets lost. Fourth, Git improves accountability. You can see what changed, when it changed, and usually why it changed from the commit history. Without version control, a lot of people fall into messy naming conventions like project-final or project final-version 2 or project final-for real, or somehow even names like project final actually final. Git is a much cleaner, much smarter answer to that problem. Git is especially important in Linux environments. A huge amount of Linux software is open source, and Git is one of the main tools used to manage that code. If you use Linux for development, system administration, scripting, or contributing to an open source project, Git is part of the normal workflow. You might use Git to manage application code, shell scripts, configuration files, infrastructure definitions, or documentation. Linux and Git also fit together culturally. Linux encourages transparent tools, text-based workflows, and automation. Git works extremely well in that world. So even if you're not a part of some giant software team, Git is still incredibly valuable. It helps you manage your own work more safely, more cleanly, and more professionally. There are a few terms you should know. A repository, often called a repo, is the project being tracked by Git. A commit is a saved snapshot of your tracked changes. A branch is an independent line of development. Branches let you work on changes without immediately affecting the main line of the project. A merge combines changes from one branch into another. A remote is a version of the repository hosted somewhere else, such as GitHub, GitLab, or another server. If those terms feel a little abstract right now, that's completely normal. Once you see the basic workflow, they start clicking into place very quickly. Let's walk through a very basic example. But first, if you have not already, you need to have Git installed on your local machine. On Fedora 43, I need to run the following command: sudo dnf install git space -y, and then enter your password. When the install is complete, let's verify the version with git space -- version. You should see something like git version 2 dot something dot something. Now, if you're using Windows or Mac OS, you can also download the binaries from https://git-scm.com/install. If you need to pause the video to do the install, I can wait. Next, it's highly recommended that you set your name, email, and default branch. To do this, we're going to type git space config -- global space user.name double quote Michael. Please type your own name here. Hit enter. Next, type git config -- global space user.email space double quotes Michael at cwm-me.com close quote. Again, please type your own email. Hit enter. Next, we're going to set the default branch, and we'll do that by typing git config space -- global space init.default branch, all one word, capital B for branch, space main, all lowercase, and hit enter. Okay, with this complete, let's jump back to our basic workflow. Now, in the terminal that we have open, let's create a directory. Type mkdir space my-project. Hit enter. Now type cd space my-project. We're inside of our my project folder now. Type the following command: git space init. This turns the current directory basically into a Git repository. This is very important. Next, let's check the status of that repository. Type git space status. Git status is one of the most useful commands in Git. It tells you what files are untracked, modified, or ready to be committed. So let's create a file called notes.txt for Git to track. In Linux, this is pretty easy. We can type touch space notes.txt. If you're in Mac OS, touch as well will work. If you're in Windows, I'm not sure, PowerShell may work. Otherwise, just open up TextPad and create your note there. Okay, after hitting enter, let's check the status again of our repo by typing git space status. Notice how it shows untracked files. It shows the notes.txt. So to track the files and stage them, let's type git space add notes.txt. Now, if you have many files that are untracked, you could select everything by typing git add dot and hit enter. This adds all new files, modified files, and deleted files in the current directory and its subdirectories to the staging area. I personally don't recommend using the dot here unless you're sure that those changes or additions should be grouped in a commit, because that's what git add dot will do. Now, you have a few other options as well. Let me show you a few other ways to stage files before we continue. You could type git space add - A. This adds changes across the entire repo. Or you could type git add -u. And this adds modified or deleted files, not new files. So keep in mind that staging means telling Git which changes you want to include in the next commit. Let's go ahead and do that. To make or create the commit, let's type git space commit -m space double quote, add initial notes for the commit here, close quote, hit enter. This will commit everything that's been staged in one commit with the message that you see in the quotes. So the message in the quotes really should be accurate in representing what has been changed. It's very common for some dev teams to include in the message the sprint ID or the sprint label. check your team and find out their preferred pattern they have. Again, that commit message should explain what changed in a clear and useful way. So if you edit the file again, you can inspect the difference with git space diff. Hit enter. Here, because we only have notes.txt and have not altered the file, the command git diff shows no changes. So let's type vi space notes.txt, hit enter. So go ahead and make a change in VI. I'm going to type I to go into insert mode, and then I'm just going to type yada yada. I'm going to hit escape, and then type :WQ to write and quit. Now, let's type git space diff again, and we see some interesting changes. So remember, to commit new changes, you first have to stage them. Let's type git space add notes.txt and hit enter. With the changes staged, now let's type git commit -m space double quote I typed yada yada close quote, hit enter. So if we want to see the history of everything we've done, you're going to type git space log. And this command shows the history of changes and commits. This gives you a timeline of your commits. And honestly, at a beginner level, this is the loop you want burned into your brain. You make the changes, you check the status, stage what you want, commit with a meaningful message, and review the history when needed. That simple workflow alone is already a massive upgrade over unmanaged files and random backup copies. If you made it this far in the video, do me a favor, leave me a comment and tell me what you're going to use Git for. And lastly, it helps a lot if you'll just click like and subscribe to my content. That's it for now. Blessings, everyone.